Okay, teardown review time. This is the Switch100 LED light bulb. This one's quite exciting. There's not a lot of bulbs in the market which are replacements for 100-watt incandescent bulbs. And more importantly, this switch bulb claims it can be used in both enclosed light fixtures and open light fixtures. So those are pretty bold statements. Also, they're offering 25,000 hour life, which is excellent. Dimmable features, they say. It uses 21 watts, so that's only on 21% of a old 100-watt light bulb, so that's certainly quite good. And we will take a look at it. Okay, so here's a close-up of the bulb and what makes it so special. Obviously, there's a glass envelope on the outside here, and those little yellow squares, of course, are the LEDs, which emit the light. More importantly, though, the area between the bulb surface and the LEDs is actually not air like most bulbs. It's a liquid silicone. And what that does, it allows a circulatory motion to be set up where the heat gets drawn away from the LEDs and then carried either to the surface here or perhaps down to the heatsink here and then expelled to the environment. What that does is keeps the LEDs temperature fairly constant, at least as constant as possible. And that's really good for service life, and that's probably what allows this vendor to claim that this bulb will work in an enclosed fixture. So just looking down the top here, you can count out 12 LEDs, 1600 lumens. That means that each LED has to produce 133 1/3 lumens, which is certainly not a remarkable figure. It's definitely, these are very bright LEDs. They appear to be single emitters as well. There's not a combination of, say, on the Cree bulb where one could see 4 individual dyes. This appears to be a single 12 die. Okay, so I just plugged this bulb into this commercial grade kilowatt. Quickly tells you the number of watts being consumed and the power factor. 21 watts was the claim on the bulb packaging. As you can see, it's living up to that claim, perhaps a wee bit above. And the power factor is 0.94, so it's probably power factor correction. So one thing about LED bulbs is they sometimes can be quite directional. That means basically they don't produce the same amount of light all around it. The original incandescent light bulb, of course, was fairly even. Now, it's actually fairly easy to do some amateur science here and see how a bulb performs. I have a light meter, and it records, of course, the number of lux, which is lumens per square meter. If I draw a circle, basically, and then measure the light along the radius of the circle, which is an equal distant point, you can then create a graph of the illumination, and it's actually quite interesting. So we'll just draw a circle here. Okay, so here's the results now. On various angles, I record the number of lux, and then I draw a line along that axis equal to the number that I recorded. And of course that results in a pattern of the light dispersal. No surprise, because the emitters on the LED are sort of at a mostly vertical orientation. It's brighter on the sides of the bulb than it is on the front of the bulb. So if you're using this bulb in a light fixture where you want a lot of light pointing downwards, this won't be your strongest choice. Okay, well, let's talk about flicker. What I have here is a solar cell, which obviously converts light to electricity. And I've connected an oscilloscope, and it's AC coupled, and what will happen is the light comes from the bulb, of course, will shine onto the solar cell, and that gets converted to a waveform that we can read on the oscilloscope. Now, LEDs, if they're driven with a DC source, which I should see, of course, is a flat line because there's no AC component. Now, for reasons of economy, sometimes happens is the vendor will actually not use a perfect DC source driving their LEDs, but they'll actually sell an AC overlay. And you can see this bulb here, the solar cell is picking up an AC waveform, which tells me that when I get to the point of tearing this down, I'm going to suspect I'll see some AC voltage on the LEDs. So as another data point in flicker, I have a Philips bulb, of course, same cell, and I'll just take a look at the noise on the oscilloscope. So this is a Philips bulb, and you can see I really can't get any sort of measurable AC ripple onto it. So kind of suggests that the Philips bulb actually has considerably better filtering on its LEDs. So what we have here is the bulb, obviously on a weight scale, weighs 282 grams. That's actually a really heavy bulb, which is probably not really much of any consequence for most applications. There's one exception. This is my little desk lamp, and I'll just put the bulb in and show you what happens. It actually looks good, doesn't it? But there's actually, it's good because I've got a beanbag on it. It's such a heavy bulb it actually tips over a desk lamp. So obviously this bulb does not work really great in this particular light fixture. This is a dimmer test. Pretty straightforward setup, of course. Got the bulb in a socket. Have a dimmer. Now, there's no restrictions on the packaging as a type of dimmer. One thing I've been noticing, actually, some bulbs actually go to the extraordinary effort to actually call it that only specific dimmers work with them. Now, no restriction here on the Switch, so I grabbed the one I had. I have a true RMS voltage meter running across the bulb, so the voltage can be indicated. You can see the bulb is gently glowing at about 30 volts, and that seems to be the lowest setting on this dimmer. Now, as I move it up in a relatively smooth fashion, you'll see the bulb snap on in terms of its brightness. So it's not linear like a traditional incandescent bulb, and then once you get about 60 volts, it does have a bit of more linearity. Now, let's just take a look at another bulb to see if this bulb is unusually poor in this regard, or if it's something that's kind of common with LED bulbs. So here we have a Philips bulb. It's a 75 watt equivalent, 1100 lumens. You can see the meter showing about 50 volts, and there's no light whatsoever coming out of the Philips bulb. And again, I'll just adjust the dial upwards, and you can see now it's turned on. That's great. And it nicely comes up, and then as we go back down again, it stays illuminated. And strangely enough, it actually, once you actually give it some voltage, you can actually bring it down a bit. So the Philips is a little bit smoother than the Switch bulb in regards to sort of a low-end luminance. Okay, well, that's sort of initial impressions of this bulb. Now, I think this is going to be a real specialty bulb because it, unless I can adjust the price, it cost me over $60 with shipping. It came in close to $80 for me to put this bulb in my hands. I honestly don't think that's going to be a very commercially successful venture. This company actually has announced that they're producing a series of much cheaper bulbs, so I guess that'll be warmly welcome. Certainly with Cree moving in with a 60 watt bulb in that $12 range, something like this is really just a scientific curiosity.